So yeah, my name is Leah Wasser, and I am the executive director and founder of pyOpenSci. And we care a lot about helping scientists tackle and essentially do better science. And specifically, we're focused on supporting better software. And then also we do a lot of work around skill development. And right now that's very much focused on packaging. So I wanted to give you a overview of what we've been doing, but I also want to say if there's questions as I'm talking, like this can also be informal if you want to ask questions and someone can stop me if there's something in the chat. I can't see the chat, but or you can just unmute and I'm happy to answer questions as I go. So we essentially have three pillars to pyOpenSci. So the first is that we run peer review process of software. And through that peer review process, we also are developing a lot of guidelines and recommendations for packaging because that is a very tricky topic, especially in the Python ecosystem. And then we also have partnerships with lots of different communities that I'll talk about. And then finally, we have an education and training arm, which is really about teaching scientists some of these skills around how do you share code, how do you create a package, what are best practices in doing that, in creating packages. And then everything that we do is supported by this inclusive community. So I'm the one presenting today, but we've got folks like Chase and other folks that are serving as contributors, community members, lots of different people are contributing to pyOpenSci. I'm just here kind of representing that work today. So I want to start with this. If you're a spatial person, this is a meme that Felipe Fernandez, the Conda Forge maintainer, created. And this is really like where I got started in Python, where I was really fighting a lot with trying to install spatial packages and then teach spatial packages to students. And I just quickly was confronted with a lot of challenges in the finding a package and then using packages space. And this is really a pretty significant usability and just like challenge in general for scientists to figure out what are the tools. Maybe they're domain specific, so maybe they are, some specific domain, or maybe they're just broader. But there's so many tools on PyPy that it can be really tricky to figure out where to find those tools. Also, a lot of the software that we're using, these are single maintainer projects. So from an open science perspective, what happens when that maintainer needs to step down, but there's a community of people using that tool? And then finally, when we think about software, the development piece is obviously a very technical process, but the use of the package, like that API, there needs to be some sort of user-friendly interface, which normally that would be documentation. And one of the things I've just noticed is that docs can be really, really technical, and that can be another pain point for scientists that are trying to actually use your software. So pyOpenSci, really the basis for starting pyOpenSci, and this started back in 2017, 2018, was we were asking some questions, or I was asking some questions like, what would happen if it was easier for scientists to find software that they needed to do their science and to use it? Also, what would happen if community tools that we all acknowledge were useful for scientists were maintained and in one place for them to find? So they weren't kind of scouring through PyPy and finding some tools that are maintained and some tools that are a few years old and trying to figure out which ones would be the best ones for them to use for their data processing needs. What would happen if a maintainer needed to step down and there was a community that could facilitate that, whether it was trying to find a new maintainer or just helping the community understand, hey, this package is being sunsetted, you might want to use this other one instead. And then again, what would happen if documentation was generally more beginner friendly? So these were some of the questions that we were thinking about when we started to develop the inclusive software peer review process that pyOpenSci has been running since 2019. So the idea of software peer review is a few things. One, the idea is that it's a constructive vetting process. So it's not your typical academic review where there might be some negative aspects in terms of the feedback that you get on a paper. The goal is to improve the quality of the software, and also over time, as Chase was talking about, thinking about standards and just maybe more consistent approaches to packaging. Through a single review process, you can begin to kind of gain that traction around let's do things a certain way. Also, we have a maintenance check process that we're going to be developing. We're already starting to talk about that with community partners on what does it look like? How do we check in with maintainers after maybe 6 months, a year? Can we do some automated checks, those types of things? And finally, and maybe most importantly, especially in the academic space, is that there's not enough credit around creating and maintaining software yet. It's this foundation for all of the open science development that scientists are doing. You need that software. And so we partner with the Journal of Open Source Software, which means that in our review process, you can also become JOS published. And I'll talk about that in just a moment. And I just wanted to highlight that this whole process is community led, which means that we've got volunteers from across the community. Right now, Chiara Marmo is our editor-in-chief. We have a rotating editor-in-chief process where every 3 months they switch. And then all of our editors and reviewers, it's all volunteer driven. Inclusion is really important too. So we focus on ensuring our review teams are diverse, that new reviewers can come in and participate in the process, even if they're vetting usability and documentation. That's still a very impactful, that's still impactful from a peer review perspective. And then we also mentor folks that are maybe newer to the ecosystem, but that want to get involved. We provide mentorship, and in some cases that mentorship has led to new reviewers becoming editors, and then they're kind of in this leadership role within the organization, which is a pretty awesome transition for them, and a great way to get different people involved in the ecosystem. So this is what peer review looks like. So you submit your package to us. The whole process is open and online on GitHub. We learned a lot from our sister organization, pyOpenSci. So we definitely started there and then have developed a Python specific review process. And at that point, we have a set of pre-review checks that we call them, that are really the basic things that every package should have. So our editor-in-chief, which is Chiara right now, will perform those checks. So those are things like, is there documentation? Are there tests? Is there CI set up for the package? Is there a README? Is there a license? Some of those really basic checks. And so that's that standardization that we're trying to get across the ecosystem of, like, packages should have these things. And so once a package passes those pre-review checks, it's fairly likely to become accepted, as long as it continues through the review process and all of the changes are made in those steps. And so in the review process, we have an editor leading that process, and at least 2 reviewers. And it's a conversation with the maintainer or the maintainer team around, hey, we think that these things would be better from a usability perspective, from a technical packaging perspective, all of those things. And that discussion happens in this back and forth that it's fully open on GitHub through GitHub issues. And then once a package is accepted into our ecosystem, we have a badge, and we then put that package on our website, list it there. The author is welcome to submit a blog post. We're going to promote the package to the broader community across all domains. And then over time, we're working on these maintenance check-ins to ensure that a package that is accepted continues to be maintained over time. And we're still developing what that process looks like. But that's something that we're doing, we will be doing with the community. So we also have partnerships with different communities. So right now we're actively partnered with Astropy, and we also have a partnership with Pangeo. And what that means is that a lot of communities have affiliated tools. And one of the challenges that Astropy and Pangeo ran into, but specifically Astropy has been a little bit more active, is that they have these lists of tools that they've vetted through their affiliated package review process. And then those lists very quickly become dated. And so we've been running peer review. We partner with Astropy. They add this additional layer of community standards around what does it look like to be community affiliated with Astropy to our review. Now we've got Astropy editors on our team that are editing for Astropy packages. And so it's kind of this really nice synergy where we're supporting Astropy because we have the infrastructure to run review. We're working with Astropy to develop standards like what are the maintenance checks and like how are we going to check in on packages over time, and also around just packaging in general. And so we've got this really wonderful leveraging of the 2 communities. in terms of resources and partnering and providing visibility for Astropy, but then also Astropy is supporting our review process. So it's a really great partnership. So finally, the big picture here is that through one end-to-end review process, you can become pyOpenSci accepted, which we're going to really focus on that Python specific review. But also, if you want to become published by JOS, they're going to accept our review as theirs. It's a quick process. They're going to fast track you through and just look at your paper. And so very quickly, you can also get a publication once our review is done. If you are, say, affiliated with Astropy or want to be, you can apply for that as well. So you can get that check of being an Astropy affiliated package. And then again, over time, we're going to check back in on the process or on the package to make sure that it's still maintained over time. So this is kind of the big picture of leveraging multiple communities and working together and learning from each other with this shared goal of helping scientists find better software that they can use, but also supporting these this growing library of tools that we want scientists to be able to trust because they've been embedded through this review process. So this is really just the big picture. Wherever we can, we try to partner, we try to leverage, we try to learn from, and we've really just been building out these partnerships and these relationships over time, which has been really great. So our peer review process, I mentioned, we kicked it off in 2019, and it was kind of a side project for me at the time. I had a full-time job, and then I was lucky enough to get Sloan funding, which allowed me at the end of 2022 to go full-time on pyOpenSci. So we've really been growing over the past year and a half, which has been really pretty cool. And I haven't looked closely at this last bar, but I'm pretty sure this quarter was related to Astropy, that partnership, and getting more packages there through that as well. So takeaways here are that, this is all about community. This is all about building better software. This is all about thinking about how do we help scientists find the software that they want, need to use. And this is our peer review guide link on the screen if you're interested in that. And I'm happy to share these slides after. So what I just went through was just how peer review works. And the next thing that I'm going to talk about is the packaging piece that Chase had mentioned as well. So we've been doing a lot of work in the packaging space to support our peer review process, because we can't have a solid peer review process without having some guidelines around what a Python package should actually look like or could actually look like. So this has also been a community effort. And I want to just start by mentioning that I had this experience, and this is not a specific to science package, but I'm a maintainer of a package called Travelib. And I really quickly learned through just that process, completely separate from pyOpenSci, that being a maintainer can be really tricky, and navigating the packaging ecosystem can be really tricky. And one of the big takeaways of that experience for me, which I know scientists are experiencing as well, is that there are so many packaging tools out there, just so many. And it can be really overwhelming to understand which tool does what. And even moreover, it can be really confusing because sometimes, like, what's the difference between twine and hatch and pypy and pip, and there's all these words, and it's like, what do they all mean? So that's overwhelming. This word cloud is a product of about 76 scientists. They asked the question, like, what packaging tools do you use? And you can just see that there's a lot here, and there's also a few that aren't packaging, like pandas, but you can just see the volume of tools, and maybe you've experienced this yourselves as well. So one of the other things in developing the peer review process has been, what do we do about packaging, and how can we make the packaging experience easier for scientists and the community in general to navigate? So in this space, what we've been doing is developing a packaging guide that provides a few things. One, it provides this overview of the packaging ecosystem and the tools and what tools do what things. The second thing it does is it provides an end-to-end, highly opinionated tutorial that gives scientists one way to do things. So there's not so many options that they have to worry about. If they just want to package their tool, their code, and it's a pure Python package, we've got a way that they can do that where they don't have to make a lot of decisions along the way. And then finally, the guidebook, one of the core goals was that it's not only accurate, but it's also beginner friendly. So we wanted something that didn't give people too many options, that didn't overwhelm people, but we also needed in that process to do a lot of review and a lot of work on making sure it was just understandable and accurate and easy to use. So that process really also involved community and a different type of review, but a lot of review and bringing together a lot of people to make decisions around what packaging tools should we be teaching. Like there's a lot of options out there. How do we help scientists focus in on tools that we think would be useful for them? So we have been working with both people in the Python core community, so like PyPA, Conda Forge maintainers, the maintainers of tools like Hatch, and pretty much all the tools in our guidebook. I've interacted with the maintainers of all of those tools, and most of them have also reviewed our content. So the idea is that we have this review process that's similar to our peer review process, but now we've got, I'm writing sections of the guidebook, and then the community helps me review, make sure it's accurate. We have several rounds of reviews. Some pages in that guidebook might have several hundred comments across multiple pull requests. And the key is getting folks that really know packaging combined with people that maybe are a little bit newer to packaging to review. So you get both that lens of it's accurate, but also that lens of, yeah, this is accessible. I understand. I can go through this tutorial and be successful. And the idea of the guidebook is that it's a living guidebook that we're going to maintain and keep up to date over time. One of the really important pieces of all of this is this focus on, rather than getting too much into the weeds of the nitty-gritty details of packaging, is to focus on people and what people need to be able to actually share their code. Like, what does a scientist need to be able to share their code? And they don't necessarily need to become a packaging expert to do that. So this whole process of creating the guidebook required a lot of navigation around opinions in packaging and various perspectives, and kind of moderating that so that we could come to a community consensus around what should a package look like and what is a good end-to-end workflow for scientists to use. So we ended up using Hatch. There's a lot of great tools out there, but as a community, we decided that Hatch was a really great way to go. The maintainer of Hatch is really forward thinking. He's super responsive. I found it to be a pretty user-friendly tool. We've tested it with several beginner packaging workshops now and had a lot of success with people creating their first package. I also really appreciate that Hatch adheres to the community standards, the PEPs that are being developed in the core Python community. And then the biggest thing for me, like kind of putting a maintainer cap on, is I don't think that Hatch necessarily locks you into a particular workflow, which I appreciate. So if we need to change things in the future, like I don't see that being a huge lift for us to update some of the content that we've created. Now, one of the pieces here in thinking about packaging specifically is that because it is so technical, breaking things down into this really focused, simple fundamentals of packaging was really critical to our process. And this is specifically in creating our tutorials. We wanted to break things down into the steps of creating a package rather than focusing on there's all these tools and you can use pip and Hatch and PDM, and like that's a lot. So we focus on, this is how you create a package structure. We do things like, yes, we advocate for the source layout. We think that's a great layout, but we're not going to force anyone to use that if they like the flat layout. So we kind of navigate some of these topics that can become a bit controversial in certain communities around packaging. And by breaking things down, we're finding scientists having a lot of success in actually getting their package to PyPy. So every workshop, we've taught 2 workshops so far, and we've had several dozen people just be able to create their first package. And then we've been using test PyPy, but they're figuring out that workflow. And then for the PyPy to Conda Forge step, there's a tool called Grayskull that you can use. And so we've been just helping people navigate that ecosystem. But again, consistently working with, so I'm constantly talking to the Conda folks and to the Conda Forge folks and the people that maintain PyPy to make sure that we're kind of also in line with the broader Python community as well. And then this is just an overview of, if you're curious what's in our packaging guide, we've done a lot of work to break down tools that people are using and then what features they have. So if you're someone that does want to pick a tool because you have preferences and maybe Flit is a better tool for you than Hatch because you want a simpler, tool that just does the basic things that you need, we break that down in our guidebook as well to help you understand how to navigate, like what tools have what features. And then again, all of this has been reviewed by the maintainers of each one of those tools to make sure that it's accurate. And then we try to update it as tools update. So for example, Hatch added support for other build backends, which opens this whole space of more complex builds and extensions and things. So we updated Hatch to account for that, and we even tested it out to make sure that it works. So far, we've tested it with Meson Python. So this number is actually already off because we've had a few new contributors in the past few days, but we've had over 60 people contribute to the guidebook, and now it's being translated into Spanish. So that's been really, really fun to see kind of it grow and start to take a life of its own. This is really a community effort. So the takeaways here are really that we care a lot about community review, whether it is, software peer review or any content that we're creating. It's always going to be a community-driven process. We also, for packaging specifically, have learned that the best path forward is to both include the people building the tools, like talking to core Python folks, and also carving out space for beginners. And this really is what creates that happy middle ground of, we've got accurate content. We're working towards a slightly more standard approach in the packaging ecosystem and a much less confusing space for scientists to navigate, while also carving out space for people that are newer to packaging to be involved, and for scientists to be involved, even if they're not packaging experts. And then there's a URL here for our packaging guide if you want to check that out as well. So to kind of wrap the whole thing up, pyOpenSci is really about kind of at a high level 4 things. We're about partnering with other communities and working together. We're about connecting scientists and maintainers and trying to find that middle ground where we can make sure that scientists are successful in sharing their code and their science. We also want to make sure that everything that we provide is usable, and that includes tools that come through our review process. And then we just want to include as many people as possible. So what that looks like is we have partnerships with organizations across the community, and we're constantly expanding those partnerships. So if there's ways for us to connect in some way that would be helpful or mutually beneficial with Open Planetary, I'm super open to that discussion. We really want to connect. So we don't want scientists that are, often there's this disconnect between people at universities that are using tools or wherever they are using tools, and then the actual maintainers of that tool. And so we want to bring those communities together. We want to help scientists find the awesome software that your community is creating, but also help them be able to use it and be able to create software or just share their code themselves. We want to make sure that everything is usable, that docs are just a little bit more user-friendly to help kind of smooth out some of those pain points of getting started with a new tool, in addition to being able to find that tool. We want to make sure that as many people are included in the process, so everything that we do is community-driven, and when we can carve out space for people to be involved, we will definitely do that. This is just an overview of our leadership team. And so you can see on the right, we've got our editorial team. On the left, we've got our advisory council and then our board. And so what's next? We're starting to think more about advanced packaging. So far we've been really focused on pure Python packaging. So like I said, we started with the fundamentals, but we're starting to experiment with other build backends to think about packages that have extensions rather than just pure Python. We're working on some more content around collaborative Git and GitHub to help people better contribute to open source, to help scientists work collaboratively online. We also are going to be doing an event this fall that's going to be a combination of training and some sprints. So stay tuned for that. And here's my contact information if you want to get in touch with me. And with that, you know, if anyone's interested in talking more, if there's opportunities to collaborate or just to, you know, talk to each other and check in here and there, that would be great. There's lots of also ways if you're interested in getting involved with our peer review process. You can go to our website, there's a volunteer page and you can learn more about that, or you're just, anyone's always welcome to email me. And then of course I know Chase, so you're welcome to connect that way as well. So thank you so much for allowing me to talk today. And then I'm just happy to chat more and answer any questions if there are questions.